We're going to continue on our section 8.5 as we look at our problems today. And the first thing we're going to need to do is realize that this is not 8.5b, very similar, but sorry, 8.5c. This is our third day. So I've got some simple steps here for solving logarithmic equations. We're going to combine the multiple logs and isolate them and group them together using the addition or the division or the subtraction ideas. Then we're going to take that single logarithm and change it to exponential form. And then finally, solve that resulting equation, remembering all the time that you can't take the log of a negative number. So we've got a couple illustrations here. Some of them are straightforward and already simplified and combined. Some of them we might have to combine first. So I just want to kind of walk us through a couple of these illustrations. So our first one, we have the log base 4 of 5x equals 1, negative 1. And I need you to realize that this log of 5x, that's not the log of 5 times x, but that's the log of 5x combined. So just very simply, let's take a look at what we're going to do here. Remembering once again, if you have the log base b of a equals c, that transforms one way or the other into b raised to the c equals a. And so I just want to remind us all of that once again as our general logarithmic transformational formula. So what does that mean? Very simply, 4 to the negative 1 equals 5x. So 1/4 equals 5x. So we divide both sides by 5, and x equals 1 over 20 as a value of x. So very straightforward. Nothing very fancy about this. We're just going to evaluate these and solve these equations. Let's look at our second one. We have the log of 3x minus 5 in parentheses. Without saying, this is a common logarithm. And remember, on a common logarithm, you do have that invisible 10 down there without being written. But a common logarithm, we can then use that invisible 10 to work it out. So we're going to say 10 raised to the negative 2 equals 3x minus 5, very simply. So 10 to the negative, sorry, that's not 10 to the negative 2, that's 10 to the positive 2. So that's 100 equals 3x minus 5. So 105 equals 3x, and 105 divided by 3 equals x. Remember those simple little steps to say, hey, does 105 divide evenly by 3? Add the 1 and the 5 up, and 1 plus 5 is 6. And so that tells you quickly that 105 does divide by 3. And so you can very quickly get, okay, that's a value of 35 as a value of x. Okay? All right, let's look at our third problem here. Log base 5 of 10x minus 3 equals 0. I always like when they have an equals 0 in the problem because it allows us to use that idea of a number raised to the 0 equals 10x minus 3. And by now you're very comfortable with anything to the 0 is 1. So 1 equals 10x minus 3. 4 equals 10x. 4 over 10 equals x. And our final answer, 2/5 equals x. So once again, pretty straightforward as we're working through these problems. Just working them out, transforming them, and simplifying them very simply. Here in this problem, we have two logarithms. And so our two logarithm situation, we're going to have to deal with the issue of, okay, what are we going to do and how are we going to approach this? Probably the easiest way to do it is to combine them into one logarithm. So we can say the log of x over 5 equals 3. So we can express that as a base 10. So 10 to the third equals x over 5. That's 1,000 equals x over 5. And so x, very simply, when you multiply both sides by 5, equals 5,000. So on these four problems, as you can see, we've got a target of trying to isolate that logarithm, taking it and changing it to an exponential form, and then once we have that exponential form, solving each one of these. Hope that's fairly straightforward. Now, let's kind of take this in more of an advanced level now and take a look at what's going to happen when we have multiple logarithms and we start combining these. All right, a number in front, this 2 in front, that is going to become an exponent. So just as a reminder, log base 3 of x squared plus log base 3 of 5 equals 2. Because they both have a base of 3, we can combine these logarithms. So let's do that. We're going to have the log base 3 of 5x squared equals 2. And I'm going to put parentheses around that 5x squared, just helping us all remember that that's all part and inside of one logarithm. Now as we solve this out, that's 3 squared equals 5x squared. So 9 equals 5x squared. So 9 over 5 equals x squared. And we're going to solve that by very simply taking the square root of both sides. And so the square root of 9/5 equals x. Okay? So, simple, straightforward problems there. You're not going to have to worry about rationalizing that at this point. We're just going to kind of work through that and go from there. Not quite sure why the homework was dropped in there as a thing. Must have been a cut and paste. Let me just erase that for us so it's out of the way. All right, our next problem. We've got log of 2x minus 3 equals the log of x minus 5 plus 1. We're going to get both logarithms on the same side of the problem here. So log of 2x minus 3 minus the log of x minus 5 equals 1. And the reason we're putting them on both on the same side is now we can combine them into one logarithm. So 2x minus 3 over x minus 5 equals 1. That gives us 10 to 1 equals 2x minus 3 over x minus 5. We cross multiply. That's over 1. So 10 times x minus 5 equals 2x minus 3. At this point, we're just crunching out the algebra. 10x minus 50 equals 2x minus 3. We subtract 2x and get 8x. We add 50 and we get 53. Sorry, we add 50 and we're going to get 47. We divide by 8 and we get 47 over 8. So just a lot of algebra there in terms of some simple things, but the key idea is going to be bringing that first logarithm over to the other side and working it out that way, and then changing it into a combined logarithm with a base of 10. Okay, well, moving on. Let's take a look at these last three, or these last four. Now, on these last four, you might be able to think through these with or without exponential form, but we're going to change it into exponential form just so we're all comfortable with that. So on our first one, very simply, I hope by now you can see that's 5 raised to the x equals 25. Leads to very quickly x equals 2 because 5 squared equals 25. Over here on number 8, we have 125 raised to the x equals 5. Well, by now you probably know that 125 is 5 cubed. So hopefully you realize that the cubed root of 125 is 5. So a cubed root is an exponent of 1/3. All right, moving down here, we've got x squared equals 81. I'm sure that you can very quickly go there and say x equals 9. And then finally, we've got x plus 1 cubed equals 8. Well, what cubed equals 8? Well, if we take the cubed root of both sides, that's x plus 1 equals 2. So therefore, x equals 1. So we've got some pretty straightforward problems here solving on each of these. But I think the big thing to realize is on these 4 problems, we have a possibility that maybe, okay, you are going to get to the point that you might not, now, you might not need to change these to exponential form. It might be a case where you can solve these, you can think through them without changing them to exponential form as you're getting better and better with logarithms. So if you can, use that shortcut. If you can't, then don't use the shortcut. And the shortcut basically is just thinking through the log and saying, hey, 5 to what power equals 25? Without having to write all that out, you might be able to just write the value is 2. So hopefully that's pretty clear and straightforward, but just changing logs to one base, transforming them, and now solving a logarithmic equation instead of an exponential equation. our homework is on the next page, as you can see, and we're going to kind of work through that very quickly and very simply.